So I'm continuing with section 1110, Taylor and Maclaurin series. Let's start with this example. Let's use the series e to the x, which we did in part 1. That was equal to the sum as n goes from 0 to infinity of x to the n over n factorial. We're going to use this to find a series for e to the x squared. So all we're going to do is put in x squared where there's an x. So e to the x squared simply now becomes the sum, then goes from 0 to infinity, of x squared to the nth power over n factorial, which becomes the sum as n goes from 0 to infinity of x to the 2n, we just multiply exponents here, over n factorial. Now we're going to be asked to do different things with this. We can multiply or divide power series. As we saw before, we could also take the integrals of them. So let's go ahead and do that. I'm just choosing to. It's not that we have to do. This is the series for e to the x squared. But let's say we were asked to take the integral. So now the integral of e to the x squared dx will simply become the integral of this series. So that would still stay the sum as n goes from 0 to infinity. And we just use the antiderivative power rule here. So we're going to have x where we just add 1 to the power here, and we divide by it as well. We need our constant of integration, so we'll just put a plus c at the end, or you can put it in front. Right, so like I said, we can also multiply or divide power series. So this example is going to be a little complicated. We're going to be dealing with fractions here. But let's go ahead and find the first few terms of the Maclaurin series, y or f of x equals tangent of x. So if you recall, tangent x is equal to sine x over cosine x. And if we go back to the Maclaurin series, at the very end, I wrote out the series for each one. So sine x, if you go back and you look at that series, our first term would be x. That's when n is 0. We would simplify that all to an x. And then because remember it was odd, we would have minus x cubed over 3 factorial plus x to the 5th over 5 factorial, and it alternates, so we would say so on there. And then cosine, we actually wrote this out in our example, that would start when n is 0, we get a positive 1, minus, and then we have x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, and so on. Well, I want to write this a little bit easier because we're going to be dealing with these, so let's actually figure out what these factorials are. So this becomes x minus x cubed. 3 factorial is 3 times 2 times 1, so that's 6. Plus x to the 5th, 5 factorial is 5 times 4 times 3 times 2 times 1, so that actually gives us 120. Then we'll have 1 minus, we'll have x squared over 2 plus x to the 4th. 4 factorial will give us 24. And then we'll just continue it after. We won't actually include the x to the 6 over 6 factorial. Because again, we just want to get the first few terms. So we're actually just going to do long division here. So this is going to be a little bit tedious, but just bear with me as we go through this. Alright, so our numerator, we're going to start with x minus x cubed over 6 plus x to the 5th over 120. And we'll divide that by 1 minus x squared over 2 plus x to the 4th over 24. Alright, so we're going to say 1 goes into x how many times? X times. So now I need to multiply these 3 terms by the x. So we're going to have x times 1 is x. Then we're going to have minus x squared over 2. And then we'll have plus x to the 5th over 24, and we'll subtract this. So now x minus x is gone. Now we're going to have, I'm going to keep this in a quantity, so we'll simplify this. We'll have negative x cubed over 6 plus x squared over 2. Oh, this should have been an x cubed, because that was x times x squared. Alright, so that's what I get when I subtract these two. Then we're going to have plus x to the 5th over 120 minus x to the 5th over 24. And I want to actually combine these now, so I'm just off to the side. Negative x cubed over 6. X cubed over 2, I'll write it as plus 3x cubed over 6, getting common denominator, so we'll get 2x cubed over 6, which is x cubed over 3. So now this will turn into x cubed over 3. And then we'll have x to the 5th over 120 minus 24 times 5, so we'll have minus 5x to the 5th over 120. Gives us negative 4x to the 5th over 120, which is negative x to the 5th over 30. So then we'll have minus x to the 5th over 30. I can't combine these because they're two different powers, so now I go back up to the top. So now 1 times what will give me x cubed over 3? Well, x cubed over 3. So now we'll go ahead and multiply. X cubed over 3 times 1 is x cubed over 3. X cubed over 3 times a negative x squared over 2, so this will give us a minus x to the 5th over 6. And this will get me my third term, so I really don't care about this last part here. We have nothing else to bring down, so we're good with that. So now we'll go ahead and subtract. So I know x cubed over 3 minus x cubed over 3 is gone. So now I'm going to have negative x to the 5th over 30 plus x to the 5th over 6. And I want to get those with common denominators, so we'll have negative x to the 5th over 30 plus 5x to the 5th over 30. So this becomes 4x to the 5th over 30. Divide both by 2, so we'll get 2x to the 5th over 15. So that's what this turns into. So 2x to the 5th over 15. That'll just get me my next term here. So 1 times this will give me this. So then we'll have plus 2x to the 5th over 15. So this would be our answer. These are the first few terms, so it'll just continue. Our first few terms of this series for tangent x. Alright, so let's take a look at one more example. Okay, so here let's find a Taylor series for f of x equals cosine x about x equals pi over 4, or centered. So remember, the only difference between Taylor and Maclaurin is Maclaurin is always centered at 0. So we're going to go through the same process that we did for the Maclaurin series at the beginning. So we're just going to start with f of x is going to equal cosine x. We'll go through the derivatives. So our first derivative will become negative sine x. Second derivative is negative cosine x. Third derivative would become positive sine x. Fourth derivative would be cosine x. So this time we're going to evaluate at x equals pi over 4. So f of pi over 4, cosine of pi over 4 is radical 2 over 2. F prime of pi over 4, this is the opposite of sine of pi over 4, so it's the opposite of radical 2 over 2. Second derivative, the opposite of cosine of pi over 4, that's another negative radical 2 over 2. And we'll do our third derivative. That will become a positive radical 2 over 2. And then even for the fourth derivative, we're back to a positive radical 2 over 2, and then it would just keep repeating. So we would have 2 positives, 2 negatives, 2 positives, and so on. So we could say that f of x, which is equal to cosine x, becomes the sum, as n goes from 0 to infinity, of the nth root, or the nth derivative rather, of f of pi over 4 over n factorial times x minus this pi over 4 to the nth power. Now as we go to start to write this out, we're going to get our first function here, that was f of pi over 4, gave us radical 2 over 2. And if n is 0, this is a 1, and this is a 1, so we just get radical 2 over 2. All right, next we'll have a negative, so we'll say minus. We'll have radical 2 over 2 over 1 factorial times x minus pi over 4 to the first. Then we'll have another negative, so it'll be minus radical 2 over 2 all over 2 factorial times x minus pi over 4, that quantity squared. Then we'll have our third derivative here, we're back to positive, so we'd have plus radical 2 over 2 all over 3 factorial times x minus pi over 4 cubed, that quantity cubed. It'll have another positive, it'll be radical 2 over 2 all over 4 factorial times x minus pi over 4 to the fourth. Then we're back to negative, because we had a positive, we have 2 negative, 2 positives, so now we're back to a negative, radical 2 over 2 all over 5 factorial times x minus pi over 4, that quantity is a fifth, and so on. Now we're not going to try to condense this into another series here, so we'll just leave it with that and it will continue. Actually, that next one would be a minus.